Hey guys, today we're going to work on expanding and factoring expressions. All right, simplify the simplify the following expressions using the order of operations. GEM-DOS, we're going to start with grouping symbols, exponents, multiplication, division, and addition and subtraction. Let's see what we remember from previous years. On number 1, we're going to do the grouping symbols first. So we'll have 6 times 12. All right. 6 times 12 is 72. Grouping symbols first. Final answer, 55. Grouping symbols first. 2 times 4, 8. Take a moment and write this in your notes. Also include this reference. How is 7 times x plus 2 different? Think about that for a second. One thing I notice is there's a variable. So if I'm looking to do what's inside the parentheses, I cannot do x plus 2 because those are not like terms. The distributive property allows the number outside the parentheses to be distributed to the terms inside the parentheses. Please write this in your notes. Here's an example. The 4 is outside of the parentheses. It is then multiplied times the x and then times the 3. 4 times x is 4x. 4 times 3 is positive 12. We can also use the area model to show this. If I do 5 times 3x, I get 15x. 5 times 2 is 10. 7 times x is 7x. 7 times negative 9 is negative 63. We're going to practice using the distributive property on these 6 problems. I'm going to distribute the 5 throughout the parentheses. I'm not able to do what's in the grouping symbol because 6x plus 9 are not like terms. So in order to simplify this expression, we will distribute the 5. 30x plus 45. That is the simplified expression. Four times 3k is 12k minus 8. 1.5 times 6t is 9t plus 3. 1/2 times 8 is 4 minus 3j. Now, we have 3 terms within our parentheses, so we are going to distribute the 8 to all 3 terms using multiplication. 8p plus 56 plus 16q. Now, one example that was not given, I want to try something. If I have a negative outside of the parentheses, this will be negative 8a minus 8. We could also be given a problem, negative times x minus 3. Now, we do not have a number with this negative sign, but we can always place a 1 there. This will leave us with negative x plus 3, because negative 1 times negative 3 is positive 3. Take a moment to include this in your notes. All right, the directions here say simplify the expression using a distributive property and then combine any like terms. So I'm first going to distribute my 6 and bring down my plus 10. I notice I have a set of like terms, so I combine those, and my simplified expression will be 24c minus 2. We'll start with distributing the 6. I have a pair of like terms, 23b plus 42. All right, I'm going to distribute the 2, and I'm going to bring down my 3x. I have a pair of like terms, and that is my simplified expression. Please pause and put this in your notes. Factoring, that should be, factoring an expression. Expressions can be factored to remove the common factor. This is how we undo the distributive property. First, we're going to determine the greatest common factor. Remove the greatest common factor by dividing each term by it. So if you look at our example, we can divide the 6x and the 15 by 3. So our GCF, our greatest common factor, is 3. So if I pull it outside the parentheses, it is now 3 times 2x plus 5. To check ourselves, if I were to distribute, I would get 6x plus 15, which is what we started with. All right, we can also do this using the area model. From this, I can divide a 4 from both of these. If I divide a 4, then I'm left with x and 4. That's actually a positive 4, so it would be written like the following. Here, I notice I can divide both by 6, and I'm left with a 2x and a positive 3. All right, let's try these. We're going to rewrite each expression as a product of two factors. My greatest common factor here is 2. If I divide both of my terms by 2, I am left with 3a plus 1. My GCF is put out front. My greatest common factor here is 3. I divide both terms by 3, I am left with 8x minus 3. To check yourself, you can do the distributive property in your head and see if you come up with the original expression. Last one, my GCF is 5. I'm going to divide by 5, and I'm left with 2x plus 7. Please include these 3 examples in your notes. When you're done with this, I would like you to go to the practice section under Tuesday in Canvas and complete expanding and factoring expressions with Cami. Make sure you submit. Email me with any questions.